Now, ladies and gentlemen, when we talk of learning curve, very good. Remember our diagram. Remember our diagram. So here we have what we call AT. AT is average time. AT is average time. And then here we have what we call a cumulative what here? Output. Cumulative output. Ladies and gentlemen, whenever we talk of learning curve, as we produce more and more by the day, if we are great people who believe in learning, as productivity increases, automatically, ladies and gentlemen, as cumulative production grows, automatically the AT for the subsequent units will be reducing. So what are we saying here? We are saying that the AT for the subsequent units that we produce must be reducing like that. So you're saying that as cumulative output increases, the average time, which is time per unit, the average time reduces. The average time of producing, subsequent units, reduces. Why? Because of the experience. Because of the experience acquired in producing earlier units, So as output increases, as this cumulative output here increases, AT is average time. The average time of producing the subsequent units does what here? Reduces, because of the experience acquired in producing earlier units, But again, remember here, there are a few conditions. A few conditions that must be met. Number one, the work must be what here? Repetitive. What we call production of homogeneous products. If, for example, you're looking at someone who manufactures, ladies and gentlemen, this kind of a particular type of a table, then all through you'll be producing the same type of tables. Otherwise, if you make a table, the first item, the second item, ladies and gentlemen, happens to be a chair, then there will really no learning taking place. Learning can only take place, for example, if it's mwalimu here. If I've been teaching this AMA, like now for the last 23 years, AMA every semester, meaning that I've taken about 46 lots to do this particular CASNEP paper, and I'm teaching just AMA alone. It means that every other semester I'll be becoming finer, like that. I'll be able to teach, for example, this particular subject in a very short duration as compared to how I could teach it when I started. When I started teaching AMA, I could not even finish the syllabus. But right now, if you give me a chance of doing this particular syllabus, teaching a group of students, I'm so sure I'll be able to finish the entire syllabus in a record, say 1 month. Why? Because I know the exact areas to touch for these students here to survive. Like now, learning curves is one of those areas that are quite important. So we are speaking about homogeneous. So because of the experience acquired while producing earlier units that are similar to the ones that you are currently doing what you're producing. So that is the first condition, homogeneous product. Very important. Ladies and gentlemen, the second condition is that the same individual individual, or a group of individuals. The same individual or group of individuals are involved in the production, are involved in the production, are involved in the production, are involved in the production. Very important condition. The same individual or group of individuals is involved in the production. Otherwise, if you keep on substituting your team members, ladies and gentlemen, at the end of the day, there will be no learning. There'll be no learning. And that is why learning curves is really against high labor turnover. High labor turnover is disastrous to us. It's disastrous to us. So the same individual is, ladies and gentlemen, used in the entire production water process. Number 3, the last condition is that there are no breaks. There are no breaks in the production chain. There are no breaks in the production chain. There are no breaks in the production chain. And that is why if you go to serious airlines, like the Ethiopian airline is a very serious airliner. If you go to them and you happen to see pilots when they come out of their leave, perhaps someone who had taken a leave of say 30 days, when their leaves are over, when they go back, they don't just go and land onto a Dreamliner 787 and then they start their flying exercise right away. No. Whenever there is a break, you always do what here, you always keep on forgetting a few things. You must do what we call a refresher. So for us to have, ladies and gentlemen, our learning curve being there throughout, we are saying something very important that we shall be assuming there will be no breaks in between. Otherwise, when there are breaks, then automatically we will be up there. Now, ladies and gentlemen, remember, if, for example, Mwalimu here was to be like a carpenter, the very first chair that I'll produce, I'm so sure, the very first chair that I'll produce may take me like 10 hours. The very first chair may take me like 10 hours. From there, we go to the second chair. The second chair, ladies and gentlemen, here, of course, because of learning curve, because there must be some learning that took place when I was making the first chair, because there must be some learning that took place when I was making the first chair. What will happen, ladies and gentlemen, the second chair will take me relatively a shorter time. Will take me relatively a shorter time. So perhaps this could be like 8 hours. And learning will continue. For example, we have in this case here the third chair. The third chair, for example, could take me like 5 hours. And then I have the fourth chair here, for example, taking me like 3 hours. But ladies and gentlemen, you and I are cognizant of one fact, that we can't continue learning throughout. Learning will have to stop at some point. It's not possible for me to keep on improving, to a level where I will reach that particular point. I'll be saying, let there be a chair. A chair springs up in 0 hours is not possible. So after some time, ladies and gentlemen, we shall stabilize. After some time here, we shall stabilize. For example, if we stabilize here at 3 hours, it means that chair number 5 will take 3 hours. And all the subsequent chairs will be taking three hours. So we have this particular line here being stable, what we call at point what here? At point K. So if I were you, I would have shown this line of stability as my point K. So this is point K like that. This is point K like that. Now exercise, ladies and gentlemen, we are given here exercise. They have given us R is 75%. A is 30. We are required, number 1, to determine the time taken to produce the first unit. Time taken to produce the first unit. The time taken to produce the first unit. The time taken to produce the first unit. Time taken to produce the first unit. Time taken to produce the first unit. And then number 2, ladies and gentlemen, time taken to produce the first, 20 units. The first 20 units, time taken to produce the first 20 units, And then number 3, we have time taken to produce the 10th unit. Let's first of all do those 3. So time taken to produce the first unit. Time taken to produce the first unit. What do we have, ladies and gentlemen? Time taken to produce the first unit. By the way, are you able to see my board clearly? Is my board clear? Or would you want me to make some improvements in terms of camera focus? Is my board clear? Thank you very much. Who says it's clear? Thank you very much. Now, time taken to produce the first unit. This is quite easy. So solution number one, time taken to produce first unit. This is automatically A. A from our learning curves, ladies and gentlemen, A from our learning curves, A is the one that designates the time taken to produce the very first unit. So whenever you see A, it's even given here. I should have written here the time taken to produce the first unit is 30. It's even given here. So time taken to produce the first unit is our A, which is what here? Which is 30. Which is 30 like that. And then we go to number 2. Number 2, they want us to give them the time taken to make the first 20 units. The time taken to make the first 20 units. So here we need the model. So our model, what do we have here? We have y equals ax raised to power b plus 1. Y equals ax raised to power b plus 1. And I would want, in this case here, my grade students here, I would want somebody to give me the formula, or rather to give me the value of b. Who can give me the value of b? Kindly give me the value of b. Give me the value of b. So y equals ax raised to power b plus 1. And I want somebody to give me this b. Remember, b is a learning index. B is a learning index. And for us to get this learning index, ladies and gentlemen, we normally take log r divided by log 2. So here we normally take log r divided by log 2. Very good. Folio, I can see folio has the formula. John has already gotten the answer. Auma has also gotten some answer there. So log r is the learning rate. So this learning rate, ladies and gentlemen, the learning rate has been provided there 75%. So then this will be log of 0.75 over log of 2, which I'm able to see somebody giving us a figure of negative 0.415. Negative 0.415. I know Uma is one step ahead of us, right? So you take logarithm. I hope you're able to see logarithm. You're able to see logarithm in your calculator there. So you say log of 0.75 divided by log 2. Log 2. If you do that, you'll be able to get negative 0.415. From there, go ahead and give us b plus 1. Thank you very much. So give us b plus 1. Having gotten this b, you can see the exponent here, the power wants us to ascertain the b plus 1. So come and give us b plus 1. So b plus 1 is negative 0.415 plus 1, which I can see Akina Maria giving us 0.585. 0.585 like that. 0.585. Thank you very much. Now, ladies and gentlemen, already I have A. And then they want me to give them the total time. This Y stands for total time. Total time. X, of course, you grade students know that X is the cumulative output. X is the cumulative output. X is the cumulative output. Now, could you then do me a favor? Kindly do me a favor. Kindly go ahead and plug in the figures to give us this, to give us the time for 20 units, to give us the time for 20 units. So here we are, I can see John giving me 173 point something. So we have here the model itself is y equals a, that is 30, x raised to b plus 1.585. So then y for the first 20, the first 20. This will be 30, 20 is quantity raised to 0.585, which will be equal to, just confirm whether Mr. John is giving us the right figure. Just confirm whether Mr. John is giving us the right figure. Confirm whether Mr. John is giving us the right figure. Yes, Sharon has been able to confirm. Please ensure that you know how to raise. The most important thing is for us to know how to raise. That is the most important thing, and ensure that you know how to raise. Even Helen has been able to get the same answer. Lucy Nyamu, thank you very much. So we have here, y first 20 is 173.07. Thank you, and thank you very much. 173.07, thank you, and thank you very much. Now, so we go to the next one. The last one, they want us to give them y first what here? They want us to give them number 3, not first. Number 3, they want us to give them the time of producing, the 10th unit. The time of producing the 10th unit. The time of producing the 10th unit, of which I would want to give you exactly a minute. Try as much as possible to give me that answer. The most important thing is for us to appreciate this fact that they want us to give them y 10th unit. So how do we get y 10th unit? Of course, this requires some kind of expansion. I'll have to come and talk of y first what here? First 10. Y first 10. And then I'll come and subtract here y first what here? 9. For me to be able to be left with the 10th unit alone. The 10th unit alone. So remember, when we talk of y first 10, so we have 1, maybe 6, 7, 8, 9, 10. So when I talk of y 10th, they only want me to account for this 10th unit there. Right? And yet remember that learning curves are basically what are cumulative in nature. They are cumulative in nature. They are cumulative in nature. So it means that when I'm expanding, I'll first of all talk of y first 10. So y first 10 means that I've taken into consideration all the units. I've taken into consideration all the units. And if that is the case, ladies and gentlemen, then I have to cut out the unwanted. And the unwanted units are here. I want to be left with the 10th unit alone. So I have to cut out the first 9. So in this case here, we have this y first 10 minus y first 9 to be left with y, which is the time of the 10th unit. So then this one here will be equal to, I have my a is 30, which cuts across. So I'll put 30 outside, and then inside the brackets here, I'll come and take care of my units here and my power. So here I'll talk over 10 raised to my power, which is 0.585 minus 9 raised to 0.585 like that. So come and give us an answer. So you say 30 times open brackets, 30 times open brackets, so we have here 30 open brackets, 10 raised to 0.585 minus 9 raised to 0.585. Please give us an answer. I know you could have used a different approach, but really we'll end up getting the same answer. So I'm waiting for somebody to confirm that indeed also Mwalimu's method is able to give us 6.9 or 6.89 or something close to that. Lucy is confirming that this method is also able to give us what here 6.9. Lucy has been able to confirm 6.9. So thank you, and thank you very much. So we look at the fourth one from this model. We look at the fourth one. We look at the fourth one. So the fourth one, ladies and gentlemen, what do we have here, ladies and gentlemen? The fourth one. So the fourth one we have here, they want you to determine the time taken to produce, units 21 all the way to 40. The time taken to produce units 21 all the way to 40. So ladies and gentlemen, I can see great students who have been able to give me suggestions there. Like one is giving me John 81.53, Cheriot Langat 81.53. We have Diana the same, Esther the same. So what these students have been able to do, which is quite an easy thing, what they have done is to come and expand this. So we have here y 21 to 40. This needs some expansion. It will be y first 40 minus y. You can see that the required quantity is 21 all the way to 40. 21 all the way to 40. So they want you to cut out the first 20. Because 21 is in the, if you look at this number line very well, you'll be able to know the exact quantity you're supposed to cut this particular scale at. Because here we have, for example, 19, 20, 21, etc. So they don't want the first 20, they want from 21. All the way from 21 is what is required. So we cut out the unwanted. And the unwanted here are what here, the first 20. The unwanted are the first 20. So we have here 30 outside, and then x now. X here we have 40. X has to be raised to the power 0.585 minus 20 now, raised to 0.585. If I do it that way, I should be able to get an answer, which most students are able to get here as 81 point what here? 53. 81.53. 81.53. 81.53. 81.53. Now, ladies and gentlemen, the moment I have these, what I need to do straight away is to teach you the concept of what here? The concept of doubling path principle. So mention there the doubling path principle. The doubling path principle. The doubling path principle. Doubling path principle. Now, ladies and gentlemen, for doubling path, or somebody is saying they're getting a different answer. Somebody is saying they're getting 86.54. 86.54 for the question they have done. Somebody is saying they're getting 86.54, and seemingly the 86.54 is what is common. 86.54 is what is common. Perhaps the students who are getting 81 point something, they were deducting 21 instead of deducting what here? 20. And if possible, those students should be able to tell us the exact area where the mistake they made, the exact mistake they made. So we don't repeat the same. Can somebody in this case here just volunteer and tell us the exact area where they went wrong? John is saying deducting 21. Don't deduct good units, Don't deduct good units. Remember, if, for example, somebody tells you y 32 to 50, what will I do? I will come and say y first 50 minus y first unwanted is 31. Don't deduct 32. Unwanted is 31. Unwanted there is 31. 32 is among the requirement. 32 is among the requirement. 32 is among the requirement. So is that okay? Is that okay? Thank you. Thank you, Caro. Thank you, Auma. So now we go to the doubling path principle. Doubling path principle. Doubling path principle. And the doubling path principle, what are we required to remember? And the doubling path principle, ladies and gentlemen, this is what we have. That as output doubles from x to 2x, as output doubles means multiplying by 2. As output doubles from x to 2x, ladies and gentlemen, our AT, our average time, remember this is average time. Our average time reduces from t to RT, like that. So as output doubles from x to 2x, there's a connection. The average time will move from t to RT like that, to RT. This is cumulative output, don't forget, cumulative output. So as output doubles from x to 2x, our time, average time, will be reducing from t to RT, from t to RT like that. Now, ladies and gentlemen, listen and listen to me very well. Given this particular arrangement, and then you get an examiner who gives you output of say 10 units and average time 8 minutes. AT stands for average time. Average time 8 minutes. And then it's giving us R of 80%. And then we are required to determine average time, for producing 20 units. 20 units using doubling path principle. Using doubling path principle, what will happen there? What I'll do is quite a simple thing. I will come here in the solution. I will come here and I have my table there. I have average time, or rather output first. I have my output here, and then I have my average time there. Output versus average time. The first output given here is 10 units. The next output is 20. The one that they want us to determine the average time is 20 here. It's 20. So I can see the concept of doubling. So the average time of 10 units has been given as 8 minutes. So remember, this is x and this is 2x. If you take 2 times this, you'll get 20. Meaning that the times must also be having some relationship. The time, this will be t, and then this one here will be RT, like that. So then come and give us what this RT will stand for. Give us the value of RT. So our RT, ladies and gentlemen, our RT, R is 80%, T is this 8, which will end up giving us 6.what here? 6.4. I don't know how they were getting that 3.811, because many of them were getting 3.811. It's supposed to be 6.4. It is supposed to be 6.4. It is supposed to be 6.4. It's supposed to be 6.4. How are they getting this 3.811? Can somebody help us? How are they getting the 3.811? Can someone help us? Because here we are required, we should not use the formula. They want us to use DPP, doubling path what here? Principle, doubling path principle. So let me give you the last one. So this one is quite an important one. So now they have given us here in the form of as an exercise, in the form of a table, they have given us here 8 average time, output versus average time, right? So here they have given us 8 and 32. And then they want us, or rather AT Here we have 10 minutes. These are minutes. They want us to give them that, assuming that R this time round is 75%. Assuming that R is 75%. Assuming that R is 75%. Assuming that R is 75%. Ladies and gentlemen, have a look at this. You see, first of all, we have to establish the doubling path principle. We must establish the doubling path principle. We must establish the doubling path principle. So how do we, 8, 32. If you double 8, you won't get 32. No. So if I double 8, I will get what here? I will get 16. And then our 16 doubled is what gives us 32. Right? So then I'll come and remember that this is x, right? So we have double here 2x, etc. So in short, the average time here will be t. The one of 16 is the one that will be rt. The one of 32, you have to introduce another r. So introduce another r, it will be r squared what here? R squared t. So it means that the one that they are asking us to evaluate is r squared t, where our r is 0.75. Rate is 75%. So we have 0.75 squared times t is the first one there. So t is 10. So could you kindly see whether this will give us 4.22? 7.5 of course is wrong. 7.5 is pretty wrong. 7.5 is pretty wrong. Maria gives me a figure of 5.6. John the same 5.6. Is there someone else who is able to get this 5.6? Is there someone who is able to give us this 5.6? Someone else who is able to see the 5.6 before we move on? I can see Lucy, Auma also 5.6. Thank you and thank you very much. But now if you look at your past papers, ladies and gentlemen, these people would want us to know how to use the doubling path principle. How do we use the doubling path principle to ascertain R? So mention there, ascertainment of R using DPP. 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 Doubling path what here? Principle. So ladies and gentlemen, if for instance you're to be given this kind of information, they give you your x, and then we have AT, average time. So here they give us 10, 20, and then here they give us 6, and or rather 8 and 6. Average time in minutes. These are units. And then out of this information, you are required here to determine R, which is the learning rate, using the doubling path principle. Determine R using the doubling path principle. Using the doubling path principle. That is your question. That is not my question. So ladies and gentlemen, this is quite an easy one. Why? Because I can see the doubles are here. I can see this is x and this is 2x. I can see 10 times 2 is 20. So if that is the case, then even the timings have a relationship. And the timings have got what relationship? This will be t and this will be rt. Remember the doubling path. As output is doubled from x to 2x, time moves from t to rt. And then I'll pick it from here. We are saying that our rt equals 6. So our r times 8 equals 6. Therefore, r will be 6 divided by 8. So 6 divided by 8 will give us 6 divided by 8 will give us 0.75, which is the same as 75%. Auma, you never got it right, but thank you for trying. Thank you for trying. Thank you for trying. Now, ladies and gentlemen, from there we go to the next thing. The next thing here is another illustration, if you don't mind. The more the illustrations we do, the better off we shall become. So we are given here x to 64. And then they have given us time, average time is 3, 2. And then we are required, ladies and gentlemen, we are required to determine R using doubling path principle. Using doubling path principle. Just try that. Here, what we need to do, you know, if they want us to use doubling path principle, if they want us to use doubling path principle, then ladies and gentlemen, double your outputs. So I need to clear the doubling path here. So from 2, if I'm to double my path here, from 2, I will go straight away to 4. So 4 doubled gives us 8. 8 doubled gives us 16. 16 doubled gives us 32. 32 doubled gives us 64, like that. And then, of course, I know the time of 64 is the one that is 2, like that. So this is T. This is RT. Keep on introducing. So R squared T. We have R cubed T. We have R raised to power 4T. Then lastly, we have got R raised to power 5. You introduce RR, eh? You don't introduce T. So then you pick it from here, the one that we know, it's average time. It's average time. So you're saying, ladies and gentlemen, that our R raised to power 5, R raised to power 5T equals 2. But we happen to be knowing T from up here. T was 3. So in this case here, R raised to power 5 times our T, which is 3, should be equal to 2. So we want to make R the subject of the formula. So please come and make R the subject of the formula. If I do that, then my R raised to power 5 will be 2 over 3. This R raised to power 5 will be 0.666, whatever. And then, of course, R will be the fifth root of 0.6667, like that. Fifth root. So now in your calculator, you need to look for the fifth root. There is a button, ladies and gentlemen, which has got on your calculator there, which has got this raised to. And then on top of it, you'll be able to see some character there written in yellow, X root. So what you need to do first of all is to punch the 5. And then because this is written in yellow color, you'll have to say shift. So 5 shift, you press this. So on your screen there, you will see fifth root, fifth X root. 0.6667, and then you say equals. So when you say equals, ladies and gentlemen, what will you be getting here at the end of the day? Francisca tells us it's about 95%. Is there somebody who is able to confirm this as 95%, the fifth root? Lucy says 92.2, Mary 92.21, rounding off errors, those are allowed. Karen says 92.2, thank you very much. 92, John, thank you very much. So I'm so sure most of you simply said 5 and then the normal square. No, we are using X root. We are using the X root. We are using the X root. We are using the X root. So I would want us to look at our past papers, 2012, December 2012, question number 1. December 2012, question number 1. December 2012, question number 1. For those of you who have got these books, it's on page number 23. Page number 23.